of ventilation. Okay. So let me just give some little brief about the ventilation. Okay, so what do you mean by ventilation? See, we are living inside the closed environment. Okay? Whether it's air conditioning in your houses, in commercial building shops, or even non-air conditioned areas like toilets, okay, kitchen, or car parking on the basement. So these kind of places, they require constant change of air. Okay, we have to change the air inside that places, inside that environment because of various reasons. For example, if we close the entire room, right, the, the doors, windows, everything. But if there are very less number of people, it doesn't matter much. But generally in the higher occupancy, you will feel little bit of suffocated. Okay, the reason is because if the air is not coming from outside continuously, there will be some decrease in oxygen levels and you will not feel comfortable. There might be some smell, okay, which has to go out, or some odor, or there are various reasons. Okay, so ventilation simply means the removal of exhaust or the unwanted, or we can say dirty air. There are multiple things you can say, or we can say removal of dirty, used air. Okay, and simultaneously addition of fresh air. Simply, this is called as ventilation. The removal of the exhaust, the air which we remove outside, that is called as exhaust, and the air which we take inside from outside, that is called as fresh air. Okay, so ventilation can be done even in the air conditioning as well. Okay, we have seen in the heat load calculation, we are calculating the fresh air CFM. Exhaust, whether we are doing it or not, it depends on certain cases. Okay, not every air conditioning requires an exhaust. Okay, so that is called as ventilation. So ventilation also helps in reduction in temperature in summer climate or hot outside conditions. Yeah, because inside what happens because of various reasons like the we have seen in the heat load, the heat gain within the room, like internal heat. That is the heat gain because of the equipment, the heat gain because of the people, right? Because of these reasons, the heat rises inside the room. So if you're taking an exhaust, so we are also removing the heat from the room, little bit, not much. So maybe around 3, 4 degrees, 5 degrees Celsius from outside, we can reduce. Okay, so that is also ventilation is also used for removing the heat up to very little, very certain level. Okay, so where are the places where the ventilation is required? Okay, the most common place is toilet, right? Because in toilets, what is there? Smell. You have to remove the smell from the toilets. Okay, and we have to give the provision, or we have to add the fresh air from outside. So there is a ventilation in toilets. We also need ventilation in kitchen. Okay, because in the kitchen again we have smell, we have smoke. Okay, we have to remove the heat, or we have to remove the water vapors. So those things has to be removed from the kitchen. So that also requires ventilation. Another place is car parking, but in basement. Okay, so because we have to remove the exhaust from the two-wheelers and the four-wheelers, so that place also requires a ventilation: toilet, kitchen, and car parking basement. So these are the most commonly used places, or the common places where we require the ventilation. But apart from that, there can be some other places as well. Okay, I'll give you some example that is not generally required, but yes, in certain cases it is required. For example, UPS and battery room. Okay, for in commercial buildings, there are a lot of number of UPS and number of batteries together, which is kept. So they generate heat. Okay, and also a certain little bit of smell as well. So if they are not going with the dedicated air conditioning system, then we can plan a ventilation system, an exhaust fan from the room. Okay. Another example is washing machine room. Okay, for example, in some certain hospitals, they keep a lot of washing machines together, and they use the hot water to wash the bed sheets or the clothes of the patients and all, and they are using the hot water and they are using a lot of detergent. So there will be a lot of smell because of the detergent and water vapors with coming from the hot water and all. So that place also we can go for a ventilation. So ventilation can be used in many places, but the most commonly used places inside any commercial and residential building is these three. That is toilet, kitchen, and car parking. Is it clear, guys? Out of that, we are going to see the toilet ventilation first. Okay, before that, one more thing we have to know. In ventilation or even in the air conditioning, there is a concept of positive pressure and negative pressure. Positive pressure and negative pressure. So what does it mean? I'll give you one simple example. Suppose I have a room or a bedroom or something. This is a bedroom. And in some corner, I have a toilet. Here there is a toilet. Now remember, whenever you open the doors, windows, any place, so some amount of air transfer happens because there is a change in pressure. Generally, when you open the windows from which is opening outside, you can feel some amount of air which is coming inside. Why is it the case? Because generally the pressure outside the building is higher, slightly higher, because of the winds, because of the temperature and other reasons. So we can feel the air which is coming inside. Same thing happens if you are opening the door between the two rooms. So if the pressure inside a one room is more, then will come from room one to room two. That happens. Okay. So suppose I have a bedroom here and I have a door. Okay. Suppose I have a door somewhere here. There is a toilet door. So if someone opens the door, okay. So which is the best case scenario? The air from the bedroom goes to toilet, or the air from toilet comes to bedroom. Pressure inside the toilets. Here we have negative pressure in the toilets. So almost all the ventilation systems, we have to provide a negative pressure. So what do we mean by negative pressure? Negative pressure simply means we have to, the exhaust should be greater than the fresh air, or we can say the return should be greater than the supply. Okay. So how does it happen? Suppose from this toilet, I'm removing 100 CFM. Okay, I'm removing 100 CFM. Okay. And from some opening or by some duct or something, let's say I'm just providing here. Okay, I'm just providing 80 CFM. 80. So there is a difference of 20 CFM. Okay, I'm removing more, I'm adding less. So if the door is open, the both rooms try to go at equilibrium. So this 20 CFM tries to rush in. It tries to come inside. Right? So we are maintaining this toilet at negative pressure. Reverse, it will not happen because we are already maintaining the toilet at negative. The exhaust is already more, right? Now we'll take an example of a positive pressure. Suppose there is one hospital, okay, and here somewhere I have a one operation theater. Okay, this is an OT, operation theater. This is a general ward. Okay, this is your general ward. Okay, here also we have a door. There is a door here. Okay. Now tell me which is best possible scenario. The air from general ward enters the OT, or the OT air enters the general ward. So we have to see where is the air more cleaner. Okay, the more cleaner air will be in OT compared to general ward. So what happens in a general ward, or sorry, in the OT, we maintain a positive pressure compared to the other areas. It's a positive pressure. So it means we are providing more CFM. So for example, suppose I'm providing here 100 CFM, okay, and I'm removing from here, just say 80 CFM. So there is a difference of 20 CFM, right? So when the door is open or there is some leakages or anything, the air tries to move outside instead of coming inside, because this room is more clean. The air which is coming inside this room, it passes through more filtration levels, right? So this is called as positive pressure. So in general air conditioning, in such kind of places, we go for a positive pressure, and for the ventilation, we go for a negative pressure. Okay. Again, if this is very biohazard level, okay, they are testing or doing some, there can be some diseases which can, which can spread and all. So it will be very airtight. Okay, that is a different scenario. Again, just talking about a general concept. Okay. Now let's come to the first ventilation, that is toilet ventilation. Now, what is most important in a ventilation? We have to find out the exhaust. You have to calculate the exhaust first. Why we are calculating the exhaust air first? Because the fresh air can be calculated as a some percentage of the exhaust. 75, 70, 80, 85%, somewhere around that. Okay. Fresh air can be easily calculated. 80% of the exhaust, or we can say 70% of the exhaust, 75% of the exhaust, in that way. So what we have to calculate, we have to find out the exhaust CFM. So how do we find out exhaust? So there is one formula, that is the air changes, which we have seen already in the heat load, ACH formula. So the formula is CFM is equal to length into width into height. It means the volume. Okay, if you are keeping everything in feet, then the volume will be in cubic feet multiplied by air changes per hour. Air changes means, or ACPH, it is a number of times you are changing the air inside the room in 1 hour. Okay, it doesn't have any unit. It is like 10 times, 5 times, 15 times, something like that. Okay, it's number of times you are changing the air. It is a unitless. It doesn't have any unit. Okay, that is air changes per hour. 2 times, 100 times, like that, divided by 60. Or else, if you are doing the calculation in terms of meter, then length into width into height. So the volume will be in cubic meters into air changes per hour divided by 1.7. But the answer that you get, it is still in CFM. Okay, I told you once, if you are using feet, right, you will get the answer in CFM. If you're using meters, you will get answer in CMS, that is cubic meter per second. But for this particular formula, there is an exception. Okay, the formula is in such a way, even if you're doing the calculation in terms of meters, the answer still comes in CFM only, not CMS. Okay, one important point here. Even if you're taking the meters here, length, width, height, everything in meters, but still you're getting the answer in CFM, not CMS. Okay, remember this thing. So for the toilets, according to the ISHRAE and the ASHRAE, we go for generally 6 to 8 air changes. Okay, but in newer versions, we can go for 10 air changes also for the toilets. So another thumb rule is that for private toilets, we can go for minimum 20 to 50 CFM per unit. Okay, but for public toilet, 50 to 70. Okay, no matter how small your toilet is, minimum 50 CFM you have to take, not less than that. Minimum 50. Okay, or up to 70. Minimum. You can go for higher if the toilet is big enough. Okay, generally it's the public toilets are not very big. Okay, but we can go for these values. Now, what about the fresh air? Fresh air can be simply taken as 80 to 85%. Sometimes we can go for 75% also of the exhaust air to maintain negative pressure inside the room. And how the fresh air is given? By the window openings, there will be door undercut. Okay? See, we have the door undercut. If you have seen in certain malls and different places, the toilet doors will not be up to the floor level. It will be little above, few inches above. Why is that? For the fresh air to come inside. That is called as door undercut. Okay. Or we can have a door grill. We can give a dedicated door grill inside the door, okay, which will be at the bottom side. You might have seen this in the railways. Okay, so that also it can be provided for the fresh air. Or we can go for the fresh air, which is not very common. This is very rare because the toilet space is already small. It doesn't have a lot of space. The space is already taken by the electrical services, plumbing, okay, maybe firefighting and all, or the exhaust duct if you are taking the exhaust from the toilets. So there is not much space left for the fresh air duct. Okay, but if it is required, you can go for the fresh air duct also, a dedicated fresh air duct. Take the fresh air from the atmosphere to the inside. Now, how this exhaust is taken? This is generally taken by the disc valve. This is a disc valve you can see. This is fitted inside the false ceiling. Okay, this is the face area. At the back, there will be a neck. To that, flexible duct is connected, which is then connected to the main duct and which is connected to the exhaust air fan. But from the bottom, you can see it like this. Okay, so there's a disc valve, 4 inch, 6 inch, 8 inch, like that. Okay. Now, how it is done? So I'll take you one very simple example. Okay. I'll just show you one example here. Suppose there are number of toilets here. These are public toilets. So there are so many toilets you can see. So first of all, what you have to calculate, you have to find out the exhaust required in each toilet. So for that, what you have to do? You have to find the dimensions first. So what is the dimension of this first toilet? It is 2 meters. Okay. 2 by 2, I think. Yeah. It is 2 meter by 2 meter. So I'll write it like this. Each toilet is 2 meter into 2 meter. Okay. Now what about the height? Okay. Height can be anything. Let's assume the height is 3 meter here. Okay. Now by the formula, exhaust air CFM is equal to length into width into height into ACH or ACPH, we can say, that is air changes, divided by, because here we are doing in meters, so divided by 1.7, right? So how much it is? 2 into 2 into 3 into air changes 10. You have to take 10 air changes divided by 1.7. Okay, so how much is it? Do the calculation in your calculators. 1 second. 2 into 2 into 3 into 10 divided by 1.7. Again, it is 70.58. It is 70 point something. So approximately I'll take 70 CF. Okay. So let's say each toilet requires 70 CF. So simply I can consider all the toilets require 70 CF. Now what about the passage area, the corridor? Okay. Sometimes what happens in the corridor, there are urinals. Okay. There are wash basins, there are urinals. So those places also have some amount of smell or odor. So how do you calculate for that? Okay, there is one thumb rule actually. You can go with air changes method, but there is a thumb rule that says we have to remove the exhaust CFM will be for passage area, for toilet passage. We take 1 CFM per square feet. Means what is the number of square feet? That is the amount of CFM. Okay, that you have to add. So in this case, okay, there's whatever is there, we'll leave it. So how many toilets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 18. So we have in total, I might have written this here. Okay. So total are 18 toilets. Or how much CFM per toilet? 70. So 70 into 18, it is 1260 CFM. Now what about the passage area? So when we calculate the passage area by using the area command or polyline command, whatever, you'll see that in the drafting. So passage area is 39.2 square meter. If you convert to square feet, it is 422. So approximate 420 CFM. So total is 1260 for all the toilets and 420 for the passage. So it becomes 1680 CFM. So the total CFM required is 1680. Okay, so we have an exhaust air unit of 1680 CFM. Okay, and from the each toilet, we have to use the flexible duct and we have to extract. And then the main duct is also there. And you have to place the disc valve. Okay, so in each disc valve, we are planning to take 70 CFM each. Okay, so how do we calculate the disc valve size? Again, go to your duct sizer. Okay, here you write the flow rate. Okay, or head loss. Flow rate, I'll write how much? 70 CFM. Head loss, we can take more. Okay, but even if we take around 480, 500, which is okay, or head loss 0.1. So what is the equivalent diameter? So we are getting 5 inches. Neck size. Okay, the exterior can be around 8 inches or something around that. Okay, 6 or 8 we can take. Okay, so this is our disc valve. Then you have to take the flexible ducts for the each branch, and this is your main duct. That we'll see in the drafting how we are doing this calculation and all. What about the fresh air? Now, fresh air here we are giving the door grills, door and the door grills. This is the door grill. You can see this one. This is the door grill. You have to provide the grill in each doors. Now, how to calculate the door grill size? Okay. That is by using the beta software, which you have seen in one of the classes. Okay. So open this. First of all, convert your background screen to white. Shift Alt and print screen. Then click on beta industrial software. Here click on door grills. Okay. Now I'll take Imperial. Now what is the NC max? The noise criteria 35 as usual. CFM, how much we are planning? 70 CFM. Maximum velocity 450 or we can take 500 FPM. Find the nearest match. So what is the nearest match? I'm getting the size 10 inch into 4 inches. Okay. So the grill which we are getting here, the length is 10 inch and the height will be 4 inch. And you have to place this here. You can only see the length. You can't see the width here because this is a top view. Okay. So width will take the approximate same as the door size, door width. Only the length you can see. Okay. Not the width. The height you cannot see. So this is the grill size which is required in each target. 10 into 4. Is it clear, guys?